Infield United. Wanted to talk a couple key issues because of the forecast, really. The forecast right now is absolutely gorgeous if you're running a combine, right? Great weather to be cutting beans right now. When you get that done, move to corn, but just excellent harvest conditions. However, not great for soil sampling and soil analysis and a few other things we want to talk about. So with that, let's get started. So here's the forecast, right? We're sitting dry in a lot of Indiana, probably more to the central and southern parts. And as you move into northern Indiana, you maybe have a little bit more soil moisture. But the forecast is just gorgeous again for harvest, but not a lot of moisture. And so the soils in some places are dry already, and they're just going to get drier still. And if they have a little bit of moisture right now, they're going to get dry with this forecast that's coming up. So I want to talk about a couple key issues in relation to the dry soil. So the first of all is soil analysis problems. So the biggest problem that we're going to have first and foremost is maintaining a consistent 8-inch sampling depth. All right, that is a problem. And the problem with not having a consistent sampling depth is that it impacts the consistency of data, right? So first of all, here's an example of soil pH and just looking at different tillage systems. Obviously, if you have conventional, that's moldboard plowing, you're flipping the soil over, you're not going to have that much stratification in terms of soil pH. But when you get to zero tillage, true no-till, or any type of reduced tillage system, you pick up stratification of soil pH, which is going to impact the results. So if we're not getting consistent sampling depth, we're not going to get consistent measurements for soil pH. And then here's some data from Tony Vine looking at different 44 years of different tillage systems at West Lafayette, and looking at the stratification in potassium in parts per million. And you can see, again, fall plow being the moldboard plowing, but when you get in any type of reduced tillage or no-till system, you pick up pretty significant degrees of stratification in the soil profile. So if we are not getting consistent 8-inch sampling depths, we're going to start skewing our data, all right? And that is a problem. So how do we deal with that right now? Well, the first thing we suggest with these dry soil conditions is hand probing is probably not the best way to go because you're not going to get consistent sampling depth throughout the day as you try to hand probe. So the best would be mechanized probing. And so even those hydraulic probes can have a struggle in these dry conditions. And so what I would encourage right now is to slow down. The pressure I know can be on, especially for the crews, to get lots of acres sampled so you can get your fertilizer applied. And that's all well and good. But if you're not getting good sampling depth, you're not going to have good results, and you're going to live with those results for the next 4 years, right? So I would encourage you to encourage your sampling crews to slow down. Don't put the pressure on them right now to get acres covered. Encourage them to do the opposite. Encourage them to slow down so they can get good, consistent sampling depth, even if that means a few less acres covered every day, because that way you're going to get more quality data. All right. The second problem with soil sampling and analysis in dry conditions has to do once we get it to the lab. So the first problem is in the field. The second problem is going to be in the lab. So here is some data from SureTech looking at soil pH measurements over the last decade, basically. And you can see, as we all remember, 2012, really dry year, and we see a major dip in the soil pH. Why is that happening? Because in dry conditions, we get an accumulation of salts, fertilizer salts, in the soil profile, in that soil sample. And when we measure that in the lab, the probe, which is supposed to be picking up hydrogen ions, can also pick up some of those salts and falsely read lower pH, right? And so that's a problem. Now, SureTech, as a lab, has adopted a newer technology in the lab for measuring soil pH. So historically, we've measured soil pH with a water pH, but due to the recommendation, which you see here on the right from Bob Miller and other scientists, they've adopted what we call a calcium chloride pH measurement, which is not subject to swings in either really dry weather or really wet weather in picking up those salts. So instead, it's going to give you a much more consistent, uniform pH reading across environmental conditions, giving you better data. So that is the standard way that SureTech Labs is going to be reporting your water pH. They'll use calcium chloride, but they'll report it back as water pH. Just like we measure phosphorus today with Malic 3, but we convert it back to Bray P1, we're doing the same thing with water pH. So that is going to be the standard measurement that SureTech Labs is using. So if you use SureTech Labs for your soil sampling, you can rest assured that you're going to have more consistent data. If you are using Waypoint Labs for your soil sampling, I strongly encourage you to request a calcium chloride sample rather than their default, which I believe is the water pH sample. So that's not going to happen unless you specifically request it with Waypoint Labs. So encourage you to do that. If Waypoint Labs is who you're using, if SureTech Labs is who you're using, you're going to get that standardized calcium chloride test done for your water pH, so you can rest assured that you'll have that data consistent. The next thing we want to talk about is potassium. What about potassium in these dry soil conditions? So here we see on the left just a picture and a reminder of how partitioning looks like in a corn crop for potassium uptake. Very little of it going to the grain, most of it residing in the stem and in the leaves and husks. And then if we shift over to the right, you see in a 200 bushel corn crop, in terms of potassium, you've got 50 pounds of K2O being removed in the grain, but you have 220 pounds being removed in the stover. And so when we get dry conditions, especially on corn ground that we're going to be going in and sampling, we're going to have a lot of that potassium residing in the stover, not being returned to the soil. And so that can cause a major swing, right? A shift in what our values might be. And so in dry conditions, you can expect a change in your values or a decline in your K2O values anywhere between 20 to 60 pounds per acre in soil test K2O. And so just know that, again, we could see a 20 to 60 pound swing, even with a consistent soil depth sample, just because of that K2O that's being bound up and tied up in the crop residue. And so that's a helpful thing to remember. And if we can get, if you shift to soybeans, on the other hand, you don't see that much K2O being tied up in the stover. So in the case of like a 60 bushel crop of soybeans, you might have 35, maybe 40 pounds of K2O tied up in the stover. So not nearly as much as you would in corn. So not as much to worry about there following soybean ground, but certainly if you're following corn ground in these dry conditions, that's a potential problem. Last thing we want to talk about is fall burndowns. So I hit on this a couple weeks ago, but fall burndowns, a lot of good programs out there. So in these dry conditions, what can you expect? Well, in these dry conditions, we're not going to have as rapid emergence of our winter annual weeds, so they're going to be smaller. That should help them in terms of susceptibility. But one th,ing that's missing on this sheet that I showed last week that I want to call out right now is the need for a crop oil. So if you're going to be running brash, which again is a combination of 2,4-D and dicamba, you want to be running a crop oil with that. So in our case, that would be Superb HC, running that at a 0.5% volume per volume. You want an oil in that, especially with these drier conditions, to really help get activity on those weeds, even if they're small. Now that's that if you're using a 2,4-D, a dicamba, or a glyphosate, right? You probably want to wait a little bit after harvest to get more of those winter weeds emerge. But if you're going to go in there with some residual, that would be like a dimetric product, or if you're planning on acres going to corn next year, you might be using simazine. Those products are not going to work as well because we don't have moisture. So they're stable on the soil surface, so you're not going to lose them. They're not going to degrade, but it's going to take time, obviously, to get moisture to get them activated to get root uptake. So you can go out, if you're planning to use those products now, you can go out and spread them now, spray them now. It's not going to be a problem, but it's going to take rain to activate them, to get them going. So hopefully that helps as we just think about fall burndowns and the influence of dry conditions that can have on them, as well as some of the other thoughts on pH and on potassium. So I hope that helps. If you have any questions, feel free to give me a shout. Thanks.